All right, this is the new unit in Algebra 2. It's Unit 8, Analyzing Polynomial Functions. So it's kind of related to the last unit. Unit 7 was Operations on Polynomials. And this is Lesson 1. It's called Solving Polynomial Equations. Okay. Previously, we have used several methods for factoring polynomials, as with some quadratic equations. Factoring a polynomial equation is one way to find its roots. We call the zero product property. You can find the zeros or the roots or the solutions. You may hear any of those three terms going forward. You may hear me say find the zeros. You may hear me say find the roots. You may hear me say find the solutions. Okay? You can find those of the polynomial equation p of x equals 0 by setting each factor equal to 0 and solving for x. Okay? So, example 1. Start with a nice easy one. We have 6 examples today, and we'll start with a nice easy one. Find the zeros of this equation. What that means is substitute 0 in for y and solve the equation. That's what I mean by find the zeros. Now, this is already in what's called factored form. This is in factored form. Okay? It's already factored. You can't factor that because it's already factored. So since it's in factored form, what we're going to do is we're going to set each factor equal to 0. Okay, and solve each one. Set each factor equal to 0. We've done this before. That means you're going to get x equals negative 3. You're going to get x equals 2. And you're going to get x equals 4. So I mean, you can circle those as your answers. I'm just going to say the zeros are I like to put them in order from smallest to biggest. Negative 3, 2, and 4. Now what that means is we will get to graphing, but that's where it crosses the x-axis, okay? Those are going to be the locations where it crosses the x-axis at negative 3, 2, and 4. Now don't get too excited. They're not all going to be that easy, and now they're going to get hard, okay? Find the zeros of this. So let me set this equal to 0 first. 0 equals 4x to the 6th power plus 4x to the 5th power minus 24x to the 4th power. Okay. Now the last example was already in factored form, so it was already factored for you. That's why it was easy. This one is not. So what you're going to do is you're going to write this in factored form and set each factor equal to 0. Write in factored form and then set each factor equal to 0. So how are we going to factor this? You're going to take out a GCF first. The GCF is going to be 4x to the 4th power. So factor out the GCF of 4x to the 4th power, and it leaves you with x squared plus x minus 6. Okay? We've done factoring a lot this year, but that's what you get left over because 4x to the 4th power times x squared is 4x to the 6th power because you add the exponents. And then 4x to the 4th power times x is 4x to the 5th power because you add the exponents. And then 4x to the 4th times negative 6 is negative 24x to the 4th. Now, what you're going to do is you're going to factor this trinomial there. Factor that. That should be pretty easy because it's 1x squared. So all you have to do is find two numbers that multiply to negative 6 and add to 1. So think about that. But it's x plus 3 times x minus 2 because 3 times negative 2 is negative 6 and 3 plus negative 2 is 1. Now it's in factored form. Set each factor equal to 0. Either 4 equals 0, which makes no sense, so we're going to ignore that in a minute, or x to the fourth equals 0, or x plus 3 equals 0, or x minus 2 equals 0. So this one's going to be x equals 0. It happens more than once. We'll talk about that in the next unit, because it's x to the fourth power. We'll talk about that in the next lesson, I mean. X equals negative 3, and x equals 2. This one you can ignore because 4 cannot equal 0. So I'm going to say the zeros are negative 3, 2, and 0. If you just circle these, that's fine. Negative 3, 0, and 2. I like to write them in order from smallest to biggest. So I guess this is a good point. This is a good point for me to say it, okay? If you look at the original problem, you can have a max, since the degree is 6, that means you can have a maximum of 6 distinct answers, meaning you can have at most 6 different answers. We only have 3 different answers. That's because this answer happens more than once, which we will talk about in the next lesson. Example 3, find all the zeros of x cubed minus 2x squared minus 25x plus 50. And this one's going to be a factoring by grouping problem. So I'm going to say factor by grouping. That's the game plan, which we've done a lot this year, so I'm hoping it's not that bad. So replace the y with 0. And what I'm going to do is I'm going to group the first 2 terms together, and I'll group the second 2 terms together. So for the first group, I'll take out the GCF of x squared, to leave me with x minus 2 in parentheses, because x squared times x is x cubed, and x squared times negative 2 is negative 2x squared. For the second group, I'll take out a negative 25, which will leave me with x minus 2 in parentheses. If you take out a positive 25, then your parentheses will be negative x plus 2, which don't match these parentheses, and you want them to match. Okay, because now the parentheses match, x minus 2 matches in both, so I factor that out to the front. And everything left over, in this case, x squared minus 25, comes in the second set of parentheses. And you can actually factor this again, okay, because this is the difference of 2 squares, okay? In case you forgot what that is, let me write that down somewhere on the side to show you. Okay, so just in case you forgot how to factor the difference of 2 squares, if you have a squared minus b squared, that looks ugly. Let me rewrite that. If you have a squared minus b squared, that factors to become a plus b times a minus b. So this is going to factor to become x plus 5 times x minus 5. Now it's in factored form. Set each factor equal to 0 and solve. Remember, the original degree is 3. That means we can have a maximum of 3 distinct answers. 3 different answers maximum. X minus 2 equals 0, solve that. X plus 5 equals 0, solve that. X minus 5 equals 0, solve that. X equals 2. X equals negative 5, and x equals 5. So you can circle those if you want, but I'm going to say the zeros are negative 5, 2, and 5. All right, example 4. Find the zeros of y equals 27x cubed plus 1. Now, I'm hoping this one looks semi-familiar to you. This is going to be the sum of two cubes, because 27x cubed equals 3x times 3x times 3x, and 1 equals 1 times 1 times 1. So this is going to be the sum of two cubes. So let me just write down that formula in case you forgot it. The formula is a cubed plus b cubed factors to become a plus b times a squared minus ab plus b squared. Okay, so let's set this one equal to 0 and let's factor it. First, I'll do 0 equals 27x cubed plus 1. The original problem, just do 0 equals that. And now let's factor. 0 equals 3x plus 1 times a squared. So 3x times 3x squared, is 9x squared, minus ab. So minus 3x times 1, which is 3x, plus b squared. 1 squared is 1. Now let's set each of these equal to 0, and let's solve each one. Let's do 3x plus 1 equals 0 first, because that's easy. 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1/3. Nice. Now let's do, we have to set this factor equal to 0, and we have to solve it. Oh boy. How can you solve this? You cannot factor it. You can't find numbers that multiply to 9 and add to negative 3. You can't think back to the earlier unit in the, I think it was unit 3, solving quadratic equations. There's 4 options. We cannot factor this. You cannot solve this using square roots. Completing the square is good if you have 1x squared, which we do not. So we're going to have to use the quadratic formula. So in case you forgot what that is, let me write that down over here. X equals opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So if you're at home today and you're watching the video, maybe copy down this formula somewhere, like pause the video and copy it if you need to. Now let's go and let's solve it. Okay, so opposite of b, opposite of negative 3 is 3. The denominator is just 2 times a, so just 2 times 9. Up top, under the radical, b squared minus 4 times a, which is 9, times c, which is 1. All right, let's keep simplifying. X equals 3. We've done this a lot in the past. We've done all different types, remember. Negative 3 squared is 9 minus 36. So we've done this already in Unit 3. 9 minus 36 is negative 27. Simplify the square root of negative 27 down to, should I do this? I'll do it down here. Square root of 9, square root of 3, square root of negative 1. You've done that a lot this year. Square root of 9 is 3. Square root of negative 1 is I. And now if this number, and this number, if these three numbers all have something in common, then you divide by that number. So they all have a 3 in common, so you can divide by 3. So x equals 1 plus or minus 1i square root of 3. I'm not going to put the 1 there. All divided by 6. And so we have our answer. Okay, we have this answer. It's two answers, one's plus and one's minus. Then we have this answer from earlier, the easy one. And we say the zeros are negative 1/3 and 1 plus or minus I square root of 3 divided by 6. So that question covered a lot of stuff that we've done earlier in the year. That was a long problem. That was a difficult problem. Here we go. Find the zeros of y equals x to the 4th minus 26x squared plus 25. So that equals 0. Now you have to factor. You might want to do factoring by grouping, but you don't have to for this one. But what numbers multiply to 25 and add to negative 26 in the middle? Negative 1 and negative 25. Then do factoring by grouping. The first group has a GCF of x squared. So I factor that out, and it leaves me with x squared minus 1, because x squared times x squared is x to the 4th, because you add the exponents, and x squared times negative 1 is negative x squared. I'm going a little fast because we've done these a lot this year. The second group has a GCF of negative 25, which will leave me with x squared minus 1 in parentheses. Notice how the parentheses match. So you factor that out to the front. Everything left over, in this case, x squared minus 25, comes in the second set of parentheses. And now we have difference of two squares. We are going to use the difference of two squares factoring rule twice. X squared minus 1 factors to x plus 1 times x minus 1. And x squared minus 25 factors to x plus 5 times x minus 5. Now it's factored. Set each factor equal to 0 and solve. X equals negative 1. X equals 1. X equals negative 5, and x equals 5. So the zeros are negative 5, negative 1, 1, and 5. Remember, the original problem in this one had a degree of 4. So that means there's a maximum of 4 distinct answers. Last one. Find the zeros of this, set it equal to 0 and factor. Okay, we've talked about, there is a quick way to do this one. Well, it multiplies to negative 12 and adds to negative 1, so you would have negative 4 and 3. Okay, what multiplies to negative 12 and adds to negative 1? Negative 4 and 3. I'm going to replace the middle term with those two numbers because I think that's what most people are going to do. The first group has a GCF of x squared. Factor that out, it leaves me with x squared plus 3. The second group has a GCF of negative 4. If I take that out, it leaves me with x squared plus 3. Factor out the GCF, which is the parentheses which match. So that x squared plus 3 gets factored out front. Everything left over, in this case, x squared minus 4, comes in the second set of parentheses. And that's the difference of two squares if I've ever seen it. So it factors to x plus 2 times x minus 2. Now, let's set each factor equal to 0 and let's solve each one. X squared plus 3 equals 0. More on that in a minute. X plus 2 equals 0 and x minus 2 equals 0. Those two are easy. That's x equals negative 2. And that's x equals 2. But when you solve this, think back to unit 3. Subtract 3 on each side. And then take the square root of each side, positive and negative. Take out the negative 1 by doing x equals positive and negative I square root of 3. So those are our roots, I'll say, or our zeros, or our solutions. The zeros, aka roots, aka solutions, are negative 2, 2. Then we have positive and negative I square root of 3. That was not an easy unit. That was not an easy lesson because it involved a lot of stuff we've done earlier in the year. And I mean a lot of stuff. Okay? And that was solving polynomial equations.